Hello, this is ITC Keerthi, working as Assistant Professor in GMR Institute of Technology, Rajam. And in our college, we are practicing this flipped learning. As a part of that, I would like to give a presentation on one topic in the course Computer Organization. And before that, I would like to give some images that represents evocation, and based on that images, please guess which topic we are going to discuss. And this is the one. And here we are having the chairs, and this is another example, and there are some group of people are there who are waiting to take tickets. If the tickets are not available, how they are going to come outside? And these are the applications of that topic. And can you guess what is this topic? Yes, this is stack organization, and the objective of my session is to impart the knowledge on organization and implementation of the stack, and at the end of the course this you will be able to know what is the purpose of the stack and what are the operations that can be implemented on stacks and applications of stacks, and how the stack is implemented by using registers and memory, and the application of the stack is postfix expression evaluation. And coming to this, what is a stack? Stack is a storage device that is used to store the information, and in such a way that the element that is inserted first will be retrieved last. And there are the two operations that can be performed on stack. One is called push operation, another one is pop operation. Push is nothing but inserting an element onto the stack, whereas pop is nothing but removing an element from the stack. And there is stack pointer, which is used to store the address of the stack, and the topmost element of the stack will be represented by using the stack pointer. And we can implement the stack in two ways. One is by using the register, another one is by using the memory. And here this is the implementation of the stack using registers, and some group of registers are grouped together, and here we are taking the 64 registers and number from 0 to 63, and this number indicates that it is the address of each and every register. And here along with that we are having the two more registers are there. One is called as data register, another one is called as a stack pointer, and two more flags are there. One is called as a full, another one is empty. Now here we can perform two operations. One is push, another one is pop. Initially the stack pointer is there at the location 0, and whenever you are incrementing, whenever you are inserting an element, the stack pointer will be incremented by 1. Like that we have inserted 3 elements A, B and C, and now the stack is at location 3 and the topmost element is C. And initially the stack pointer is 0, and I told there are two flags, one is full, another one is empty. Empty is set to 1 and the full is set to 0. And we'll see how do you perform the push operations. So in the push operation, what you are doing is, first of all you need to increment the stack pointer by 1. So initially the stack pointer is at 0, and if you want to insert one more element, first the thing is you need to increase the stack pointer by 1. So for that, this is the micro operation, and after that you need to write that the data is available in data register. The data will be stored onto the top of the stack. So the operation is the data that is there in the data register will be stored into the top of the stack. And if you keep on increasing that stack pointer, at some period of time the stack will be full. And here whenever you are inserting an element, you need to check the condition whether the stack is full or not. That can be checked by using this stack pointer. If the stack pointer is 0, that means if you keep on storing the elements onto the stack, the last element that will be stored onto the stack is at location 63, and once you are increasing the value 63 by 1, again it will be going to this location 0. And in that case, if stack pointer is 0 and if full equal to 1, we can say that the stack is overflow. And if the stack is full, what we need to do is that we need to make that empty to 1. So here, the empty to 0. Earlier if the stack is empty, it is represented with 1, now it is represented with 0. This is nothing but push operation. Similarly, removing an element from the stack is pop operation. So these are all the different steps that are there in the pop. So in pop operation we need to decrease the stack pointer by 1. Before that, first of all we need to read the element from the stack, and that should be stored into the data register. This is the micro operation, and after that the stack pointer has to be decremented by 1, like this. Now whenever you are removing an element, after some period of time there are no more elements in the stack, that is nothing but stack underflow. Here we need to check the condition before you perform the pop operation. So here the stack empty condition is this one. If stack pointer is 0, then empty will becomes 1, and you need to specify the full, and it is 0. So this is the implementation of the stack using registers, and it is the other way of implementation of stack is by using memory, and here this is the memory. So generally memory will be consisting of a set of instructions and a data. So it is partitioned into two parts, and this is the entire memory, and this consisting of 4000 memory locations. And for the implementation of the stack, we are taking some part of the memory, and here we are taking that part from 3000 to the 4001 for stack. Now here we are having these registers. PC is used to store the address of next instruction to be executed. It is associated with this part, and if you want to take the data from the memory, the data will be taken through address register. And as I told, stack pointer holds the address of the stack. The topmost element address will be stored in the stack pointer, and the data is available in the data register. And here again we will see how to perform the push and pop operations. So here, unlike the previous one, whenever we are inserting an element, the stack pointer is incremented by 1. But here initially the stack pointer is at location 4001. Now if we want to perform the push operation to get the address 4000, we need to decrease the stack pointer by 1. So this is the push operation. We are decreasing the stack pointer by 1. Afterwards, whatever the data that is there in the data register will be placed into that location. Similarly, pop operation. So pop operation is nothing but removing an element, and here we need to increase the stack pointer by 1. So before that we need to store the data that is there in the stack, top of the stack, into the data register. After that we need to increase the stack pointer by 1. Now here we do not have the computer will not check any conditions to check the stack overflow and underflow. And then how do you check that one? So there is most computers do not provide the hardware to check either stack overflow or underflow. Then what could be the solution for that? Here we are maintaining the two registers. One register is to store the address of the upper boundary of the stack, and one register is used to store the address of the lower boundary of the stack. And these are the applications of the stack. Here I would like to show you one of the application from infix to postfix. So this is the one expression which is there in the infix form. Infix means the operator is placed in between the two operands. Now by using the stack, how we are converting the infix expression into the postfix expression? So it will be like this. This is stack. Whenever you are getting an operand, that operand is sent to the expression. Now whenever you are getting an operator, that operator will be placed onto the top of the stack. So if you consider this expression, A will be represented in the expression. Next, operator star, that operator star is inserted at the top of the stack. After that you are getting B is assigned to the expression, and after that plus. Now plus has to be added onto the stack. Now here plus is having the lower priority than star. That is the reason first we remove that highest priority element from the stack. That is the reason we are keeping that into the expression. After that we are adding the plus here. Now C is an operator, C is an operand that is added to the expression. After that star is added to the stack. After that D is added to the expression. There are no more elements in the expression. Now you will be popping all the elements from the stack. So the elements are star and plus. This is nothing but your postfix expression. So one of the application of the stack is converting from infix to the postfix. And other application is postfix expression evaluation. I would like to explain this with an example. And this is the postfix expression. So 4, 5, 6 star plus. So whenever you are getting any element or operand, that will be inserted into the stack. Next 5 is inserted onto the stack. Now 6 is inserted onto the stack. Now whenever you are getting the operator, you need to perform this operation on the top most two elements on the stack. Now 6 into 5, 30. After that you are getting the plus. Again this operation has to be performed on the top two elements on the stack. Now the result is 34. So like this you can practice this example. This is the one. and for this the solution is this. And another example, this is another postfix expression evaluation, and if you this is the answer for this. And this is the mind map of the topic, and we have discussed about the stack organization. The stack, the purpose of the stack is to insert or storing the elements. So two operations that can be performed is, one is push, another one is pop. And push is nothing but inserting an element, pop is removing an element from the stack. And stack can be implemented in two ways. One is by using the memory, another one is by using the registers. And the topmost element will be specified by using the top of the stack, that is stack pointer. And during the insertion, we need to check for the stack overflow, whether the stack is free or not. And during the pop operation, we need to check for the underflow, whether the elements are there or not. So this is about the mind map of the topic which I have discussed. And here I am showing the some of the applications of stacks in computer science. These are the applications. And here, if you want to perform the reverse of a string, and for that we can use the stack. We take each and every character in a string onto the tag. We will be inserting that character, and by popping, the topmost element will be retrieved, which is the last character in the string. That is the one of the application. Another one is undo. So most of the times, if you want to do the things undone, so there also that is the one of the application of the stack. And in the long-range processing, the local variables and the parameters that we are specifying will be stored into the area of the stack in the memory. Another one is compilers. So we are using the left brace and right brace, and the number of braces matching will be done by using the stack. And during the function calls, the stack has to represent the written address. That address will be stored also in the stack. These are some of the examples, real-time examples of the stack in your computer science. And coming to the summary, stack is a storage device which is used to store the elements, and two operations can be performed on stack. One is push and the other one is pop, and we can implement stack in two ways. One is by using the registers, another one is by using the memory. And one of the applications of the stack is converting infix expression into the postfix expression. Another one is postfix expression evaluation. So this is all about the stacks. Thank you.